So bring me back to the study on choline. Bring me back to why you even approached that for a study, for further investigation. What did you find out? I'll repeat this stuff. What did you find out? And then, of course, we'll go into your follow-up as well.
All right. Thank you for asking. This is a study that we are doing over the long haul. So we've been at this probably about a decade now. And I know your audience is familiar with choline. There's a lot of discussion on Facebook groups and various forums that family members talk about choline, and that's fantastic. We love it when the work that we're doing here in the laboratory and in academia gets out into the public. In fact, we published a paper last year that was meant for people to read. That's a little bit less scientific jargon, a little bit more information about practical things about how to use choline. And we're hoping that families read that and pediatricians read that and that they start discussing how to do this amongst themselves. So the choline study is about an essential nutrient. So choline is a nutrient that we consume in our food, and many people don't necessarily consume enough of it with a typical North American diet. So in children, we know that this is important for brain development. The nutrient is a building block for certain parts of brain development, and it's a building block for some of the chemicals, one chemical in particular that helps our nervous system function. Super important nutrient, very important during pregnancy as well. So pay attention to that if any of your audience is pregnant or planning to become pregnant. But we decided to try to use this nutrient to see if we can optimize development that's still taking place after a unfortunate situation like prenatal alcohol exposure. There's nothing we can do to reverse the prenatal alcohol exposure itself. That happened, and whatever disruption in the developing nervous system happened, we can't reverse that. But we can optimize the rest of the development that is happening by making sure the child's brain has everything that it needs and then some to continue to develop. So that's the idea here, is not to erase damage or deficits or go back in time, but to really use this nutrient to continue to build the brain. Now, we're doing this in
Hey,
young
sorry,
kids.
that's cool. So just stopping because my audience is just listening and now they're processing what you just said. It's not necessarily a fix. What it is, it's a helper. It allows the brain to reach its full potential and help with its growth and development, even if there's been impairments caused by prenatal alcohol exposure. Am
That's
I
the
saying it
idea.
right? Correct me, dude.
Yep, that's the idea, is that we're trying to capitalize on the development that takes place in this particular case. We're talking about a part of the brain that's involved in memory, especially. It's called the hippocampus. So that's really continuing to grow out into the fourth year of life, and that's what we're trying to optimize. So it's very specific. We're not, this is not a cure-all. This is not a behavioral intervention. It's not meant to make FASD go away. It's meant to just try to tweak the development of this one part of the brain that is still growing and finishing itself out during the third year, fourth year of life, up to the third and fourth year of life, maybe even into the fifth. So that's the study. We're giving kids choline. In the beginning stages of the study, we gave choline or placebo. And that is how you do a proper test of something, is you randomize people to get what the thing that you're studying or to get something that doesn't have that in it. And then you can do the comparison after you've collected enough data. So I'll
Okay,
tell you about the
now,
follow-up study.
yes. Okay, cool. So what did we find? Let's keep going because it's awesome.
So in the initial study, we did find that this is a pretty tolerable intervention, that most kids in this age range can take choline without a problem. And we did it for 9 months. So parents were giving this to kids for 9 months. We chose that 9 months not because we know exactly what the right length is, but because that's a period of development in which there's enough change that we should be able to measure a difference between the choline and the placebo or the non-choline. And what we found there was that there were some improvements in memory for the kids who got the choline. 9 months later, we measured their memory again, and we saw that there were some changes. So there were some improvements or some advantages for the choline. They're small, they don't blow the roof off, but they're measurable, and The really critical part for you and your audience to understand is that development is an additive, continuous process. And so when you intervene at an early stage, you are taking advantage of all of the development that's going to follow that point in time. And you have leverage. You have a bigger advantage to the end result when you do it early. It's like sitting on the end of the seesaw instead of sitting in the middle. You just have more leverage to have an effect. So that's why we're doing it in these young kids.
And
People
that's the age group,
oftentimes,
right? So it
yeah,
was that's the study, the age group. And then we did talk about older kids, and it didn't show in the study. It's good to have, right? It's good to have part of your diet.
for this particular effect, we're thinking that this is going to be most effective in kids under
Right.
5 and under. This is something that is in your diet, and it is important to have an adequate amount of in your diet. But I don't believe that there's any data to suggest that supplementing someone who's a teenager, for example, is going to have this effect, this brain development effect. If you're not eating enough choline, then it's probably good to supplement choline for a lot of reasons. Your body needs it as well as your brain. But for this particular effect of optimizing brain development around memory, we think 5 and under is really where the action is.
Has anything in the study looked about gene expression? Because that's obviously an important part of choline with that. Did you look at
Yes.
that? Are you, or am I jumping
We
ahead?
have. No, we have looked at that. We have a collaborator at Rutgers University who's looked at some gene expression changes in the blood of the kids who were in the original study. So we collected their blood pre
Hmm.
and post, before and after, and that showed some changes that would suggest that choline was having an effect on gene expression. We don't really know what's happening in the brain as far as gene expression. You can't get in there and take a sample very easily or at all. So
Hmm.
we're measuring this in blood, and we think there might be, we think it's showing us that there's some changes in gene expression. It's a very complicated process,
Yeah,
gene expression.
agreed. Agreed. That's
Mhm.
why I just dabbled a little bit in that stuff because I understand some of that stuff. Where I stopped when I had to learn about splenium, I was like, okay, now we're talking about different parts of the corpus callosum. I'm gonna back
Yeah.
out. Beep, beep. That's where but I'm interested in it, and we don't have to get that deep. Let's talk about the follow-up. Let's talk about because this you first published, it was you did 9 months, and then was it 2.5 years, the gap because of the follow-up, correct?
It was almost 4 years. Yeah. So we did a follow-up study at around 4 years. The kids were now 8, 9, 10 years old when we saw them. They had not had any choline from the time that they finished the study until the time that we followed them up 4 years later, or they had basic dietary choline. They didn't have anything from us. And so we brought them back and looked at the kids who got choline way back 4 years ago and the kids who got placebo 4 years ago. And we were able to detect some differences and
So I just want to see
advantages for the choline.
if I got this right. 18 kids were the initial placebo trial, right? And so approximately 7 years after the trial, the kids were initially 2.5 to 5 years old when they were first involved. Then you did the follow-up study, which you did executive functioning tests, you did MRI. If I was a little bit more regulated, I could say the whole word. You did MRI scans focusing on the corpus callosum's white matter structure. And that's when I stopped there because I was like, oh yeah, what about it? And then they're like, spelenium. That's the word of the day, by the way, but we're gonna back up. That you
So
did
I'll
that, and
tell
I'm
you.
not, and then tell us, like, drop the goods. What happened?
I'll tell you about the 4 year study, and then Blake can tell you about the 8 year study.
Okay.
Okay. The 4 year study, we found that there were improvements in the choline group for nonverbal aspects of intelligence and also for memory. The basic idea that we had was these would be permanent effects. If we intervened way back here at age 2, 3, 4, and 5, they would be still measurable at
Awesome.
school age in school age kids, and that was in fact what we saw. Again, small effects. We're not blowing the roof off. We're not curing FASD, but we're optimizing a little bit of development that still has a chance to take place.
So you can help me clarify this then and break it down when we talk about it wasn't like a huge jump, but it says various low order executive functioning. So, for those who don't know, regulars of the podcast, executive functioning, planning, organizing, sequencing, problem solving, abstract reasoning. Now, these were little kiddos, but what is a lower order executive function? What would that mean?
I'm going to let Blake take
Yeah,
this one
Blake, sure,
because
sure.
Yeah.
this was what we saw in the 8-year study.
Oh, sorry. I don't
Yeah.
mean to be jumping around. I'm
Oh, no
excited
worries.
and yeah, okay, cool.
Yeah, so this was our longest term study that we've done to date. So this was about 7 to 8 years on average after kids got that initial trial of choline or placebo. So that 4-year study that Dr. Wozniak was mentioning, we had a portion of those kids come back at this much later time point. So about 7 years after they did the trial. And there was 18 kids, so we had equal numbers in each group who received either choline or placebo. And we were able to look at some of these skills that you're talking about, these executive function skills. And we also had kids do the brain scan, so we could look at those white matter pathways. And what you're talking about, Jeff, is those lower order skills. So these are things like how efficiently and how quickly a child processes information. And
Okay.
this is really important for some of those more complex skills that you're talking about, things like planning, things like working memory. You really need to be able to process information efficiently to be able to do those higher level skills. And so we do think that these findings are interesting and might have real world applications for these kids.